Hello students, welcome to video teaching. It's math first for class 10. In this video I will discuss different conditions for solvability or consistency of a pair of linear equations in two variables. There are three such conditions. First condition is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. This is the condition for infinitely many solutions. For a pair of linear equations of form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. For this type of pair of linear equations, if we get a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, then the pair of linear equations will have infinitely many common solutions. And the graph corresponding to this condition is a pair of coincidence lines. Means the graph lines coincide each other. Right? When we represent such pair of linear equations in graph, by graph, the two graph lines overlap each other, coincide each other. Okay? So in this condition, graph line are coinciding, and the condition is a1 upon a2 equal to b1 upon b2 is equal to c1 upon c2. Okay? Now second condition. Condition for unique solution. Unique means only one solution. So condition for unique solution is a1 upon a2 not equal to b1 upon b2. In this condition, the pair of equation has only one common solution and the graph lines intersect at a point. Means the two graph lines have one point in common. Means they intersect at a point. They are intersecting. Okay? For unique solution, condition is a1 upon a2 not equal to b1 upon b2. And the graph is a pair of intersecting lines. Okay? Two graph lines are intersecting. Well, now third condition. Condition for no any solution. In what condition a pair of linear equations in two variables has no any common solution? Condition is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. In this condition, the graph lines are parallel to each other. Parallel lines, two parallel lines we get on representing such pair of linear equations graphically. Okay, two parallel lines do not have any point in common. Hence, if the graph of a pair of linear equations in two variables are parallel lines, then such a pair of equation has no any common solution. Okay. Once again, let's revise it. For a pair of linear equations in two variable of form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. We have three conditions to determine whether the pair of equation is consistent or inconsistent. Okay? The conditions are: first is for infinitely many solutions. It is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Right? This is the condition for infinitely many solutions. And if a pair of linear equations in two variable has infinitely many solutions, then the two graph lines are coincidence. For unique solution, condition is a1 upon a2 not equal to b1 upon b2 And in this condition, the graph for the two equations are intersecting lines. Means the two graph lines intersect at a point. Condition for no solution is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. And in case the pair of linear equations in two variables has no any common solution, the graph representing the two equations will be parallel. Okay? In this case, graph lines are parallel. Right? In first two condition, means in case of infinite solution and unique solution, the pair of equation is said to be consistent. And if the pair of linear equation in two variable has no any common solution, no any solution, the pair of equation is said to be inconsistent. Now, let's see the condition for solvability of a homogeneous system of a pair of linear equations. A pair of linear equation of form a1x plus b1y equal to 0 and a2x plus b2y is equal to 0 is said to be a homogeneous system of a pair of linear equations in two variables. For such a pair of linear equation in two variables, we have two conditions. Condition for unique solution is a1 upon a2 not equal to b1 upon b2. And if a1 upon a2 equal to b1 upon b2, then the pair of equations has infinitely many solutions. Well, today I will send homework based on this topic, based on the topic conditions for solvability of a system of a pair of linear equations in two variables. Well, okay, more in this chapter we will discuss in next video. That's all.